Hello everyone, my name is Amit Kumar Mohanty. I'm an educator at Mentor for you. So in today's class, we will have to go to the question where it is asked us to determine the total value of the double summation involving the inverse trigonometric function. Now, in this particular question, what we can see, we had to generally, if we just ignore one of the summation, what we can see, it is the general summation as summation of s equals to 1 to 10 tan inverse r upon s. So if I just explore the inner summation and keep the outer summation as it is, or let's say I keep the outer summation as it is and explore the inner summation. So we want to look into what are the different types of combinations that we can form, or I can say what are the total number of terms that will be generated. First, I need to calculate them. So to calculate that, first we need to explore like how is the each and every summation is opening. So let's first. So I equals to summation of r equals to 1 to 10 and summation of s equals to 1 to 10 tan inverse r upon s. Let's say if I'm keeping the inner term summation as constant, I'm just opening the outer summation. Yes. So in outer summation, which one is variable? R is variable. Yes. So you can see if R is the numerator. So you can see if I just open the R particular term, you can see summation of s equals to 1 to 10 tan inverse 1 upon s plus summation of 10 upon 10 to s equals to 1 tan inverse 2 upon s plus summation of s equals to 1 to 10 tan inverse 3 upon s dot 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 till up to summation of s equals to 1 tan inverse 10 upon s. Now, in this particular question, the main thing that is happening is you can see for each particular term, now we have to find out the summation of s terms. Like what is the meaning that I want to say is let's look into this particular term. Now, in this particular term, what is happening? The r value is fixed, which is 1. So 1 upon s summation of s equals to 1 to 10. Now, in this particular situation, what will happen? Think. If I try to find out what will be the all of the terms of this particular summation, it will look something like this: 1 upon 1 plus 1 upon 2 plus 1 upon 3 plus 1 upon 4, dotted up to 1 upon 10. Clear? This is the one way of opening this particular summation. Now, let's go to the next particular summation, which is summation of s equals to 1 to 10 tan inverse 2 upon 5. So in this type of situation, how many summation? Like for s equals to 1 upon s, there were 10 summation. Here also, there will be also 10 summation. And how will the summation look like? It will look something like 2 upon 1 plus 2 upon 2 plus 2 upon 3 up to 2 upon 10. Clear? In that particular way, how many terms I can decide? So for each individual term, what did I know? There are 10 terms. And such 10 terms, how many terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have total of 10 terms, and each term I can expand into 10 more terms. So total how many terms? 10 into 10. I hope this is clear. So total there will be 100 terms. In this particular term, what is happening? Let's first look into it. So I equals to summation of s equals to 1 to infinity. We have written this term. Now let's s is what? S is a particular operator, or you can say a variable that is changing. Let's instead of x, let's change it to x. Okay. So in this type of situation, how will the new summation look like? So I equals to summation of x equals to 1 to 10 tan inverse 1 upon x plus summation of x equals to 1 upon tan inverse 2 upon x. And in such particular way, last term will be tan inverse 10 upon, it will be not s, it will be x. Clear? Now, in this particular term, this is the first equation that we derived. Clear? Now, let's go to the original question and try to find the second equation. So I equals to, this is the original question. In the same function, what did we did? We kept the s as variable as the previous term. Yes, you can see what was happening. Tan inverse r upon s, it was the particular term. Yes, in this particular situation, what is happening? The s is remaining constant and r is variable. Now, in the next term, what I will do? I will keep the r as constant and keep the s as variable. So how will the new summation look like? Summation of I equals to summation of r equals to 1 to 10 tan inverse r by 1 plus summation of r equals to 1 upon 1 to 10 tan inverse r upon 2. So now let's exploit each and every term. So if I look into this particular term, tan inverse r upon 1, if I try to explore it, or I can say expand it, how will it look like? It will look something like 1 upon 1 plus 1 upon 2 plus 1 upon 3 plus 1 upon 4. Clear? Now, up till up to 1 upon 10. Yes, that is one thing that I can understand. Or will it be any different? So in this particular situation, it will be different. So in this particular situation, what are we doing? We are keeping the r as particular my constant and s is a fixed value. So the r will be changing here. So 1 upon 1 plus r is what? The numerator. So the denominator will remain constant. So 2 upon 1 plus 3 upon 1 plus 4 upon 1. This is the dotted up till 10 upon 1. This is the summation of first terms. Now, with the remaining terms, what I can see here also, if I try to expand the second term, this will also look something like this: 2 upon 10. Yes, or how will it look like? Do you think? In the second term also, there will be total 10 terms, and each, what is happening? The R is variable in this situation and the base is constant. So basically the number will be 1 upon 2 plus 2 upon 2 plus 3 upon 2 plus 4 upon 2. So this is how the numbers are changing. Now in this particular way, there will be how many terms? 10 terms. So it will, last term will be 10 upon 2. So for each particular term, there are how many terms? 10 particular terms. So in this particular equation, now let's perform the same thing where I'm keeping R as X. Now, if I replace R as S, what is my new particular summation of terms? It is summation of X equals to 1 to 10 tan inverse X by 1 plus summation of X equals to 1 to 10 tan inverse X upon 2 in that particular way. Clear? Now, the main thing that I can see here is if I look into the first equation. In the first equation, what is happening? This is the first equation. The numerator is changing and the denominator is remaining constant. Clear? Now, in the second equation, what is happening? The numerator is remaining constant and the denominator is changing. Clear? These are the two equations pointing to the same line. Now, let's add both of the equations. So it will be become I plus I will be 2i. Now, in the right hand side, what will happen? This summation of, so now look into each summation. So this is the first summation. Yes. Now, let's look into the first equation. In the first equation, what is the first term? Tan inverse 1 upon x. And in this particular equation, what is the second term, first equation? Tan inverse x upon 1. So if I try to put the summation together, it will look something like this. Tan inverse 1 upon x plus tan inverse x. Clear? Now, let's look into the second term. What is the second term in this the summation? Tan inverse x by 2 for second equation. Now, let's go to the first equation, second term. First equation, second term is tan inverse 2 upon x. Clear? So if I write both of them together, because I'm adding all the sums, so summation of x equals to 1 to 10, tan inverse 2 upon x plus tan inverse x by 2. Clear? In this particular situation, each we are having 10 terms. So in this particular way, whole there will be summation of 10 particular terms, dot up to 10 terms. Clear? Now, one of the particular equation of inverse trigonometric identity will come to the handy here. So one thing that we know till now is we have up till y value 2i is equals to summation of all these terms. Now this is our equation 3. So let's proceed forward and try to understand which of our type of inverse trigonometry identity we can use to solve this particular question. Clear? Now let's go into that particular part. So what we know, tan inverse 1 upon x is cot inverse x. Yes, tan inverse 1 upon x is equal to cot inverse x, and tan inverse 2 upon x is cot inverse x by 2. So in that particular way, what I can write now, this is the particular main identity. Tan inverse x plus cot inverse x is equal to pi by 2. Now, switching back to our original question here. In this situation, this is what? Tan inverse 1 upon x plus tan inverse x. Now, can I write this tan inverse x as tan inverse 1 upon x? What will be my new answer? It will be how much? According to my identity, it will be cot inverse x. Clear? For each and every term, if I write it down, tan inverse 2 upon x will be cot inverse x by 2. Clear? Now, in this particular term, what will happen? All of this particular 1 by x will be now can be inverted into cot inverse x or x by 2 in this particular situation. So now, if I'm writing down all the values, what is happening? Tan inverse x. Now, this is tan inverse x. Now, this is becoming cot inverse x. So tan inverse x plus cot inverse x is how much? Pi by 2. That is the identity that we are using here. You can see the next page. This is the main identity. So as a particular result, what I can see now, this particular summation is how much? Pi by 2. This particular summation is also pi by 2. And this particular summation is also pi by 2. And remember, each particular summation will have how many terms? 10 terms that will be variables. So if I proceed to the next line, what you can see, each and every term is replaced by pi by 2. Clear? Now, we need to understand total how many pi by 2s are here. So let's calculate for each summation. So one summation is 10 into pi by 2. Yes, for each particular term, it is pi by 2. Now, for each particular summation is 10 into pi by 2. Clear? So it is how much? You can say basically 5 pi. Clear? Now, with this 5 particular pi for each particular term. And subsequently, how many terms are there? Look into the original equation here. So summation of this is how much? Pi by 2 multiplied by 10. So this one is 10 pi by 2, or I can say 5 pi. For total summation of one particular term. Let me change the ink for better understanding. So this total summation value is how much? 5 pi. Now, in this particular way, how many total terms are there? 5 pi. Total 10 terms are there. So if I try to clean it up a little bit and try to write the total value, it is becoming 10 into pi by 2 into how many terms? 10 terms. So the ultimate value will be 10 into pi by 2 multiplied by 10. Remember, this came from the initial summation, which is this, and this type of summation were 10. So we multiplied here 10. So total there is how much? 50 pi. Correct. Now the 55 is the value for how much? 2i. What is my target to find I? So I will be equals to 25 pi. I hope this is clear. Yes. Or in other words, if you try to understand what is happening here, what you can do is try to write the particular values in other particular way. Let's say you can write in terms of, so tan inverse x upon 1 plus tan inverse x upon 2 plus tan inverse x upon 3. In that particular way, dot up to tan inverse x upon 10. That is the particular method first for the first step if you are keeping the x as constant. Clear? Let's change the x. Then how will the terms look like? So it will look something, if I make it a tabular structure, then if I take x as 1, this all will become 1. The next term will be tan inverse. How much? Think I kept the top as constant and changed the section. Now this one will be 2 upon 1 plus tan inverse 2 upon 2 plus tan inverse 3 upon 3. Tan inverse 2 upon 10. Clear? Now, in same particular way, what will happen? There will total of 100 terms. So tan inverse, how much? 3 upon 1 plus tan inverse 3 upon 2. Now, in this particular situation, what one thing that is understandable in this particular situation is, like, look into here. What is here? Tan inverse x by 3. Or I can say, if I put x as 1, tan inverse 1 upon 3. Correct? And here what we have, tan inverse 3 upon 1. So you can see for every tan, I can have a opposite interval. Clear? Or I can say every tan inverse, for every tan inverse x, I have a tan inverse 1 by x. You can see for tan inverse 2 by 1, I also have a tan inverse 1 by 2. Any particular number that is present from 1 to 10, I have an inverse of all of those particular numbers. So that particular result, if I add it up, it is becoming how much? 50 pi for 2i. And as a particular result, 2i equals to 50 pi. And I will be 25 pi. Clear? Yes. Remember why it is pi by 2 for what is the identity that we are using here? It is tan inverse x plus cot inverse x is equal to pi by 2. And another identity is tan inverse x is equal to 1 by cot inverse x. Yes. Yeah. So yeah, this is a particular question. Thank you. Take care. Remain safe. And if you want the PDF of this particular solution, you can go through the description. The PDF link will be present there. And if you want to book a demo class or have any doubts you want to get clear, you can drop a mail at mentor4u2024@gmail.com. Thank you. Take care, and we will meet in the next class.